For Lab 7, we're going to be using Atwood's machine in order to help us calculate the acceleration of two different masses. So we're going to be using one pulley for the first part and another pulley for the other part.
So for materials, we're going to use the next ones. We're going to use the main pulley, which is going to be for both parts of our experiment that are going to hold the string of the experiment. Then we're going to use two hangers that are going to hold the weights of our experiment. Then the weights that they have to be different in order to do the experiment correctly. Then we're going to use a string that is going to hold both hangers. We're going to use a sensor which is going to read the motion of our experiment. And for the second part of our experiment, we're going to use a second pulley, so in order to do the experiment. So for the first part of our experiment, we're going to set up our pulley in this way. And what is happening here? Well, so we have our pulley set up, and we have this hanger with the heavier weight at the top, and we're going to let it go in order so the sensor can read the motion of the experiment so we can calculate our acceleration.
For the first part, this is how our graph came out. It's going to have the initial speed at 0.019 seconds with 0.96 meters per second, and then the final speed was 0.531 seconds with 1.8 meters per second. For part 2, we're going to be using two pulleys, and we're going to use this one as our mass 1 and this one as our mass 2. Mass 1 is going to be 150 grams, and then mass 2 is going to be 100 grams. For the second part, this is how our graph came out. So it started at 0.013 seconds with 0.83 meters per second. And then for the final speed, it ended at 0.414 seconds with 1.34 meters per second.
Good morning. I will be explaining the data that we got from the two pulley systems that we experimented on. So the first thing we did was find the theoretical acceleration using two different masses, one bigger than the other one. So mass 1, we picked 10 grams, and mass 2, we picked 5 grams. So to get the theoretical acceleration, we needed to find mass 1 minus mass 2 divided by mass 1 plus mass 2, and all of that would be multiplied by gravity, which 9.8. And to calculate that, 10 minus 5 over 10 plus 5 times 9.8 gave us 3.27 meters per second squared. And we just did a table showcasing that our mass 1 was 10 grams and our mass 2 was 5 grams, and of course our theoretical acceleration being 3.27 meters per second. So the second thing we did was find the experimental acceleration using the same masses as before from the theoretical acceleration. So what we did first is we found the experimental, and our first velocity was 1.8, which was our final velocity, and our initial velocity of 0.96 meters per second divided by our last time, which was 0.531 seconds minus 0.019 seconds, and that gave us 1.64 meters per second squared. And calculating that, we found the percent error, which was 50%, which is a little high, but it would make sense based on the masses we picked. And the second acceleration, we did two pulleys in the system, so we needed to find different masses, and our masses needed to be greater than 50 but less than 200, and there was a condition that needed to be met, which was mass 1 minus 2 times mass 2 would have to be greater than or equal to the absolute value of 50. So the masses that we picked was 150 and 100, and what we first did was find the theoretical acceleration. So the formula for that was negative 2 mass times 2 minus mass 1 divided by 1/2 times mass 1 plus 2 times mass 2, and all of that multiplied by gravity, which is 9.8. And that gave us a total of 2.8 meters per second squared, and that is our second theoretical acceleration. And back to the condition, 150 times 2 times 100 gave us 50, so it does meet the condition of being greater than or equal to 50. So now we have our theoretical acceleration for two pulleys set up. Mass 1, 150 grams, and mass 2, 100 grams. And theoretical acceleration, 2.8 meters per second. And then for our last table of table 4, it was the experimental acceleration for two pulleys set up percent error. So again, we did the same thing as we did before using the experimental acceleration. So our velocities were 1.34 meters per second minus 0.83 meters per second, and we divided that by the times respecting their velocities. So it was 0.414 seconds minus 0.013 seconds. And that gave us 1.27 meters per second squared with a percent error of 54%. So the percent error was higher than the previous percent error of the one pulley in the setup.
As part of our experiment, we'll be interviewing our scientist, Gabriela Ruiz. So my first question to you is today's percent error greater or smaller? Why?
It's greater because there are more factors that play into the pulley, like friction and the different masses that you pick.
Between today's two setup, which have a more significant percent error?
The setup with the two pulleys, because it had 54% of percent error, and the first one that had one pulley had 50%.
Last question, what other factors besides your friction could contribute to your percent error?
The masses that you choose, if you pick two masses that are too far apart, then the theoretical acceleration that you pick might be a lot higher than the actual experimental acceleration, and it might be harder to obtain. So the percent errors vary depending on the masses that you choose.
In conclusion, we observed at how different pulley setups work. At first, we saw the Atwood's machine that behaves as a single system that shares the same acceleration for both masses. Then we saw a two-pulley setup that changed the mechanical advantage to produce different accelerations for both masses. Then, at last, we discovered a way to balance the two-pulley setup system to create a zero acceleration but keeping the constant velocity.
I did the calculations, the data analysis, and I played the scientist.
I did a setup of the experiment and I did some of the procedures and the conclusion.
I helped set up the sensor and helped set up the pulley system.
I was in charge of editing and recording this video and also helping set up the experiment.